Hello and welcome to this episode of Conscious Design. I'm your host, Ian Peterman, author of the Conscious Design book. And I'm really excited to have Yaron. He is the founder and CTO of Nostromo, where they're transforming commercial buildings into viable batteries using water. Welcome to the show.
Thank you very much, Ian. I like your podcast, and I hope that this episode will be as good as the other.
Absolutely. Well, this is going to be a great episode. Before we dive into water as for batteries, let's talk a little bit about how you got started, your origin story. What got you to decide, hey, I want to try to turn a commercial building into a battery? Like, that's a big, ambitious task.
So it's a kind of a romantic background story. I was in a middle life crisis, and I decided that I would like to do something more significant with my life. It was 2009. So I turned from being director films. I was film director for 15 years, commercial, TV, music videos, and so forth in Israel. I decided to change my career, and I went to the clean energy arena, since I thought that this kind of activity will benefit the world in a better way, and I will go sleep. I'll have a better sleep, and I will be more satisfied with the outcome of what I'm doing in my life. So I started with not knowing what will be my part in this role. And from 2009 until 2016, I was working for and partnered with several startups. The main things I was occupied with is energy management for commercial and industrial facilities, big data analytics of, floating, a lot of inefficiencies of the procedure of production and so forth. So when I went into Nostromo, and I will describe in a minute how that came to happen, I already had a very, very good understanding of the distribution of electricity and the inefficiencies of this system. And the biggest thing I had in my mind that baffled me is that a great deal of our energy production goes to thermal comfort cooling, meaning up to 40%. Well, not worldwide. Of course, in Canada, it will be different. But here in California, for sure, all the Midwest and in the Southern Belt in United States, and all the hot countries, which become more and more, Europe, countries are getting hotter and hotter, and the cooling demands are getting greater. And of course, in India, it's crazy, and the whole Southeast Asia. So cooling demands are rising. And at peak demand, when the grid is suffering the most, cooling can occupy easily 40%. Of course, there are places in Saudi Arabia that it can get to 60%. But this is a huge amount of electricity and carbon emission related that we are designated just so we will feel nice and at the exact temperature, in the room that we are in. So this is the knowledge that I came through. And the other thing that I knew that is a common knowledge is that energy storage is the only path for renewables. So renewables can start slow and nobody cares. But once solar, and here in California, there is about 22,000 megawatts of solar production. This is 22 gigawatts on solar, meaning midday you have 22 gigawatts coming from solar, and 6 p.m. you have zero. This is a crazy instability, and at a certain point, there is saturation. At a certain point, there is this point that you cannot put more solar because the instability of the frequency will kill you. So you need storage. As we speak, 98% of the installed storage are lithium-ion batteries, which are very contaminating, have high degradation, and they have safety issues. That's why they are in the Mojave Desert, but not inside buildings. All of the consumption comes from buildings and, machines. So in the Mojave Desert, there is no consumption you need to deliver all this electricity into the cities, and the distribution system is collapsing. So I knew that storage is the holy grail. And I heard that everybody are talking about lithium-ion batteries, but lithium-ion batteries has many downsides. And I said there must be a better solution, to run after. So this is the two things that I when I was working in my last startup, it was very clear. There was another trivia knowledge that I carried with me, and that was just because I'm a curious person. And it's quite an amazing piece of trivia. This is the latent heat of water. So I'll tell you that the latent heat of water, meaning the energy that needs to be invested in water in order that they will change phase into ice, is the highest in nature. Actually, it's the second. I'll be candid with you. It's the second highest. The first one is ammonia of liquid turning into solid rock. Is an amazing process. You think about the energy needed to take liquid that I can pour on you, whatever amount, and nothing will happen to you, to a solid rock of ice that I will, if I will throw at you 10 pounds of it, you might be killed. I mean, this is becoming a tough, ice is very tough. So think about it. What is the amount of energy? This is not a change in temperature. This is not getting from 1 centigrade or 33 Fahrenheit, 34 Fahrenheit into 32 Fahrenheit. This is not the procedure. This is not the temperature that rule or conduct this amazing, I would say, magic. The turning of liquid into ice, the changing phase. Just imagine if we as human beings could change phase. What would that mean? The changing phase itself requires a huge amount of energy. This is the latent heat. So just for your perception, if you would like to freeze 1 gram of water from liquid to solid, you'll have to take 80 calories from it in order that it will freeze. But if you would like to melt this 1 gram back from 34 to 33 Fahrenheit, just 2 degrees of Fahrenheit, you'll have to invest 1 calorie. Actually, the definition of 1 calorie is the ability to rise or to reduce 1 centigrade of Celsius from 1 gram of water. This is the definition of calorie, 1 calorie. So think about it, that you need 1 calorie to reduce the heat or to increase the heat of 1 gram of water with 1 centigrade, but you'll have to put 80 calories in order to melt 1 gram of ice or to freeze 1 gram of ice from liquid to water. So there is a huge amount of energy that is hiding inside this changing phase. It was a trivia that I learned, years ago before. But at this point that I got to this decision to go for Nostromo, I said, all right, if water are so potent in cold energy per se, and the biggest need of the grid is storage and cooling, why not finding a way to combine? So the idea was, if the problem is storage, the need is cold energy, and water can actually do that, and water are pretty accessible, and cheap and available. Why not finding a way, an engineering solution, to combine very efficiently these buildings to water and turn buildings into energy storage batteries, meaning that they can take electricity, turn water into ice and then use the ice to cool the buildings instead of electricity at times of sunset. I had only this idea. I didn't have a solution, but I have a pretty good conception about the problem. And what I sold to my investors when I started the startup was not the solution. It was a direction of investigating, and told them, look, this is going to be big. If we will solve the engineering, it needs to be solved to get there. And I don't believe that solving this engineering question is so big. We need to freeze water in a way that building can be retrofitted with it. And that's all, The first $200,000 that I got was just describing the problem and direction of solution. The round, pre-A round, that was $4.5 million, was already having a prototype in my hands. So the ice brick, our solution as the mule or the muscle that holds cold energy, was already presented to the investors at the second round. But the first round was just, give me $200,000, we'll find a solution. That's what we did, actually. So the big secret that I was aware of, just because I'm a curious person, and this is a known secret, is the latent heat of water. And water has the highest latent heat in nature, only second to ammonia. The meaning of that is water is the most potent substance in nature in order to hold cold energy. I will give you just an understanding what is latent heat. So turning from liquid to solid, this is a great effort that anything can do, any material can go through. You can just imagine the difference between a block of ice and liquid water in a can. This is an amazing change. This phase change does not happen just because you are lowering your temperature from 33 Fahrenheit to 32 Fahrenheit or from 1 centigrade to 0 centigrade. This is not how it actually occurs. It occurs by investing a lot of energy after getting to the point of 0, or from the other way around, going up from 31 to 33, going through the phase change point. There is a huge effort invested in order to turn this liquid into solid, which these are very, very different state of the material. So the latent heat, meaning how much energy you need to invest in order to change plastic from solid to liquid, or water from liquid to solid, or any material in the world, metal, has latent heat, figure. And water has the highest latent heat in nature, only second to ammonia. This is a crazy information. So I will finish with an example. In order to heat 1 gram of water with 1 centigrade, you need 1 calorie. Calories, if you did diet, you know that calories are well, used. 1 calorie, the meaning of 1 calorie is the possibility to heat 1 gram of water with 1 centigrade. This is the meaning of the word calorie. This is the amount of energy needed to heat 1 gram of water into 1 centigrade higher. If you would like to melt 1 gram of ice from solid to liquid, you'll have to invest 80 calories. 80. That represent the latent heat of water, meaning the potency of water in holding energy in the form of change phase and not temperature difference. So this is the other last trivia I had in my head. And combining these 3 trivia or 3 knowledge pieces, the buildings are consuming a huge amount of electricity in the form of cold energy. And storage is the next big, need in order to enable renewables. And water can do the job of storing cold energy in buildings. So everything came together and combined. And that's how I came up with the direction of investigations for my startup, not with the solution yet. In order to get to the solution, I had to raise $200,000 from my investors, which is actually my family. It was friend and family without friends. And they believed me that I can take $200,000. They were convinced that I can take $200,000 and transform them into a prototype. And that's what we did. And with this prototype, we raised another $4.5 million. And until this day, we raised about $30 million in order to be commercialized. So there we are. So my startup was established not upon an idea for a solution, but more upon for an idea for a problem and general direction that how we're going to solve it. And my siblings, my sisters and brother and my parents actually believed my enthusiastic approach and they say, we think we can do that. So they gave me $200,000. They actually the first investors in the company.
Amazing. There's a lot to unpack there, but I love the fact that you started off with there's a problem and there's a general direction. Let's really investigate it and really approach it from how can we really engineer a solution instead of, let's just build a company right away and just kind of skip. That's a very important step of proving, it's theoretically, right? Because you add all those pieces, right? It has the energy in it. So clearly it has, there's energy there.
I'll be candid with you. The problem that I recognized in 2016 was way less understood than it is now. And still the participation of commercial buildings, which this is our main, targeted, big malls, airports, terminals, big office buildings, hospitals, which are great users big users of air conditioning. The role of the owners of these buildings into the renewable, transition is yet to be educated and we need to let them understand how they can become, we call it grid interactive assets. We need to educate them about it and show them. So this is a hard task, but we have so much support, in what we're doing. And I will tell you later about what our achievements are. We're sure that we're on the right way that every owner of commercial building will know that he has a possibility to turn his asset to have another, income revenue and to support the grid by selling the relief for the grid. And this is something I would like to emphasize as for this time, 2024 in California, when the sun is setting down, the grid is losing 22,000 solar productive megawatts. 22,000 megawatts are being produced every day or almost every day in California from solar energy. The meaning of that is that California is great with its solar and it's very poor in its sunset. When the sun is setting down, all these power stations are lost for zero. At 7 p.m., there is zero solar production in California. So the grid is going through an immense instability procedure, and therefore pushing into the grid every day, every sunset, a huge amount of electricity that's being produced by peaker power plants, which are the most polluting and inefficient, and the first one to be retired on the grid level if you would like to go and proceed with your, renewable goals. So we are now becoming a supplier of services to the grid, which are in great need and greater need by the day, which is to give the grid relief. We are selling relief to the grid at the time that the sun is setting down. So in a way, we are supplementing or completing the lost energy from the sun on a local basis. It's called distributed resources or behind the meter, somewhere where actually the consumption is being made, which is the end user. We are taking care of the problem at the core, the base where it is being, created. And this is the consumption of buildings after sunset. We can reduce this in order to support this instability of the grid. And this service, as we believe, and we are portraying, this in everything that we do, this service's revenue or value going to be greater by the day as long as solar will keep penetration, and the threat of instability of the grid will be greater. And believe me, even today in California, it's a huge deal. It's called the duck curve. You might have heard about it. It's a huge deal.
I love this concept because from a couple of things. One is absolutely there's obviously hesitancy especially if you're an airport. You can't move to solar energy because you'd only work when the sun's up. Like you can't be green and the airport needs to work at night. You don't want it shutting down at 7 p.m. when the sun goes down, right? So creating this massive ability to even out that energy, be able to store it all and harness it. I also love it as an idea because, when let's say you've invested a bunch of money in a building, you own one of the high rises downtown LA. There's, decreased people working in offices. There's decreased rent. We have these structures here though, right? And so using your technology, you can take a office building that may not have full capacity, but if you turn it into a battery, now you get this additional revenue stream. It becomes really valuable in another new way, which, I'm all for. Let's make the grid as green as possible. So let's do that. But it's also really creating the financial case to go, yeah, it's worth it because you're going to install this, and now you're going to be able to, hey, this isn't just you put it on and feel good. You'll do it, you'll feel good about it, and it'll pay for itself. And it's not just a lost feel good.
Of course, there is an IRR on our, the investment into retrofitting your building into a grid interactive asset. And there is a plan now that we are part of it, which is the DOE LPO. It's the Loan Program Office of the Department of Energy of the United States that finance 120 buildings, and they can rise up to 200 in the contract that we're now signing. 120 buildings, a good portion already signed, so there is less available, but will be fully financed by the Department of Energy. So the building owners, we are suggesting now to join this program, which building owners will pay zero down payment in order to do this transition, which is around $2 to $3 million in cost, and they will only enjoy savings to 20 years with zero down payment and investment on their behalf. And this is an amazing, opportunity to explore the vast support of the Department of Energy and the United States in the federal government in turning, the grid into a cleaner and less inefficient in many ways.
I'm also thinking of this, right, especially DOE. They think about things like security and safe, right? How do you keep the grid and power on? How do you reduce brownouts? How do you reduce potential
stability,
threat?
Resilience,
right?
Resilience. Yeah. The instability of the grid is now the biggest threat is the sunset. So it's less terror attacks and more sunset.
We can't change the sunset. It's going to happen every day.
Yeah. And we presume that it will happen in the next few years on a daily basis. So look, it's like a train running into, a cement, wall, because the goals for renewable are so high. Then you choose to use lithium-ion batteries. Lithium-ion batteries you can use them for, 6-10 years. They are degrading. And after they're being degraded, you need to, to put them into the ground, because there is not a viable, really, way to reuse lithium-ion batteries for next, after the next use. So they are going into landfills. And we already know that everything that goes into landfill comes back into our drinking water. I mean, this is a vicious cycle. We wouldn't like to support these lithium-ion if we can support it with using water. This is our statement. Be water, my friend, like Bruce Lee said once. Be water, my friend. Yeah, I mean, water, our systems are filled with water, and after 30 years of usage, you can drink them. This water are encapsulated into 30 years, and they are reusable after 30 years. And there is no use at all for rare earth materials, for, exotic metals, crazy things that goes with the battery industry. And it's totally safe, of course. So actually, into building, you can't put lithium-ion batteries at 1.4 megawatt hours like we have in the Beverly Hilton here in California, in Los Angeles. You cannot put 1.4 megawatt hour of lithium-ion batteries into a building. If you're not totally safe, you'll never be totally safe. Lithium-ion batteries can, fail. And when lithium-ion batteries fail, it's a big drama. It's a drama. There's a lot of happening when lithium-ion battery catch fire.
So how long, because we're talking about longevity, right? Lithium batteries, they last 6 to 10 years. I know that there's other batteries that people are working on, different salts and iron and things like that, but they all have a lifespan. They all run out. There's no...
Well, solid state batteries, which is the new kind of batteries, will not have a lifespan that you can call. I mean, it will be 10,000 cycles. It will be many, many, many years. 10,000 cycles, it's like 30 years, nothing less after. Even I'm not really lasting more than 30 years. Well, I'm dragging myself into the 50s, but 30 years, it's a lot of time. So there is no problem with the next generation of batteries. It seems that they will be compliant with all the needs. But the cost of solid state batteries will be very high, and it will take many years until it will get there. I must say that solid state batteries are going to be very safe as well. But we are in the gap of 20 years from now, I believe, until solid state batteries will become available in a very cheap price, cheaper than lithium-ion batteries today. I believe we have 20 years ahead, 15 years at least. Until then, the world needs to be already like 100% clean from solar energy. So I don't think that solid state batteries will take a big place in the grid scale energy storage arena. It doesn't look like it's going there. It's going this direction.
Hey, it's Ian here. So glad you're enjoying this episode of Conscious Design. If you want the full scoop on conscious design, what it is, how we do it, how you can do it, then check out our book. We wrote it so creative entrepreneurs like you can code social and environmental responsibility right into your brand's DNA. You can download the first chapter for free. Link is in the description. Enjoy the rest of the episode. Don't forget to like, subscribe, and share.
Talking about price, right? And you said it costs a few $1 million to install, but that seems relatively low cost compared to trying to stick a bunch of, not that you can, but if you were trying to do it in lithium, it would be a lot more money. Where are you in pricing?
So this is not right. It's counterintuitive because water are fairly cheap, but the on-site engineering and labor, has a massive cost. And here in California, this is crazy. The labor costs are really crazy. But we chose California because of the income, not of the expenses, but the revenues. So there is a lot more on-site work of, piping and installing of our system than compared to lithium-ion batteries. But since the material is you say dirt cheap, so this is like water cheap material of that actually store the energy. I believe that we are now at about $1,000 per kWh installed, which is about twice the cost for behind the meter installation of batteries. The front of the meter in the Mojave Desert costs less than $500 than kWh. But if you do a project inside the building with the permits and, the engineering of inside the city, it will rise. We believe we have our, information. It's about 800, maybe $650 per kWh installed with all the engineering and on-site, work, which is much less for every project than Mojave Desert with a 40 megawatt hour or 200 megawatt hour. There is a economy of scale. So you lose this economy of scale when you go to distributed resources like 1.4 megawatt hour in the Beverly Hilton and not 200 megawatt hours in the Mojave Desert. So the cost of behind the meter energy batteries is unexplored yet. People don't really know how much kWh of installing of lithium-ion batteries cost, because there are very, very little projects done, and they always be outside of buildings. Like if you have, some space outside of buildings, they will never be inside buildings. And we are aiming to take downtown LA with all its, sky rises and turn these buildings. We don't have space to put these batteries on the road or somewhere outside of the building. So our technology is fully compatible with retrofitting existing buildings inside the buildings, inside, the machine room or the other available space in a very modular, concept, and to do what has never been done. And this is to turn these huge consumers of chiller and cold energy into behind the meter or on-site city batteries that we believe that can, shape the whole new way of looking at grids into the city, because the grid that goes into the city and needs to be electrified for the heating resources to give you EV charging and whatever is struggling with all these new loads coming in, and the distribution system is old enough to not be, able to, meet our dreams of being fully renewable. That will not happen without huge upgrade of the distribution system, which is the biggest problem. This is the elephant in the room, is upgrading your distribution system and not putting solar. Putting solar is easy. Production of energy, solar or wind, is practically easy. There is available, mature technology. You can just put it, you forget about it for 20 years. At least with solar, it's almost, a hit and run. With energy storage, it's totally different. There is not available solution to take Los Angeles in the city and take off these huge loads coming on to the local grid. The local grid will not bear 100% renewable, meaning that at sunset, you will supply 100% of the electricity from the Mojave Desert. There is no way that the local grid can bear this. But if you will take it off from the buildings and you will charge it through early morning and dawn, when there is no electricity, the level of consumption are very, very low. So you're not burning the grid while charging. So there you balance the whole distribution system. Then you do something right. You're doing something right. So this is where we are aiming.
Now, with your system, when you install it into a building, does it reduce, because you're using ice, are you able to reduce the amount of air conditioning systems? Are you able to help the building directly as well? Or is it just energy?
Yes. So directly, I mean that we are influencing the main meter, which this is where your electric bills goes to. We are reducing the main meter by reducing your cooling demands. We cannot do anything else other than cooling as for today. We don't do electricity, but the building has, now it's 90 degrees out here in LA. And if I could share my screen, I could show you that the Beverly Hilton is using 40% or 35% of its energy, total energy, towards cooling the Waldorf Astoria and the Beverly Hilton. These are the two adjacent, buildings that we're serving, the Waldorf Astoria and the Beverly Hilton. So as we speak now, it's 12 p.m., 30% or 40% of the electricity going into the Hilton and the Waldorf Astoria is designated the cooling. This is how much potential we have to cut off or to shave or to lower at when the sun is setting down, meaning from 4 to 9 p.m. when the on-peak time occurs. We are avoiding the highest, of course, electricity cost, and that's where the customer is enjoying reduced, electricity cost. If you would like to have a grasp of how much we are saving, so that will be around 30% of the cooling cost on annual basis can be cut off with our system. 30% of your cooling. So if 40% of your electric bill goes for cooling, there you have a good 15, 12% reduction on your total bill. This is something. And you are saving carbon, which we cannot quantify at this moment. We cannot put a price tag on it, but there are good signs that carbon emissions will be, worth a lot in the next 5 to 10 years. And for example, I'll give you the local law 97 in New York City that kicked in just this January 24 and state that every excess metric ton of carbon for commercial buildings inside New York City, which most New York City is commercial buildings, every excess carbon emissions, directly or indirectly. When you use electricity, somebody else is emitting your carbon, but this is your carbon liability. Every excess metric ton will cost $268. This is how it's stated in Local Law 97. You can Google that. And people are baffled with how that's going to outcome, what's going to be happening through this year and how it will be enforced. But this is the first, sign for carbon liability that comes to the step door of commercial building owners. They need to understand that they have a huge part in this, plot of carbon emissions. They are biggest users of electricity, the commercial buildings. They can be 40% of the total consumption of buildings. And actually, buildings in the United States are 74% of the total emissions comes from buildings. Because who uses electricity? Buildings, whatever they are. So the commercial buildings are a great part of the total building segment, and cooling is a great part of the commercial building segment. Therefore, we believe like about 10 to 12 or 15% of the total grid demands at peak demand. I must, be very precise here. At January, we're not saving, 15% of the total peak demand of the grid. But on August or September or June or July, which are the most important and sensitive parts of the grid, and the grid is all designated to supply electricity to these months, not to January, as for today. So we will take off a great deal of portion where we'll be able, or potentially can be a viable player, a really strong player in the grid relief business, or it's called, demand response or DER, all these services that give relief to the grid in time of stress, which will, be coming on a daily basis. The stress at summertime is on a daily basis comes to the grid.
Does this play into, because the idea of like microgrid and things like that, does this fit into that concept?
Of course. I would say to you, if somebody is asking what is a microgrid, I can tell him every building can become or in the process of becoming microgrid. You don't need to be 100% off grid in order to become a manageable microgrid for 50% of your energy usage. So when you think about microgrid, this concept, actually you can compare it for becoming, a proactive user. Meaning you have resources, you have some production, some storage, some recycling of your gray water. This is another, when you say microgrid, there is a microgrid for your, gray water, black water, and whatever. You take off the big grid some of the responsibility for your doing, and that's what makes you on the verge of becoming a fully microgrid. Or you don't need to go fully be independent in order to look at every effort that every end user is doing in order to balance his consumption, his needs for peak demand, his related emissions. So you become a proactive user. I think that microgrid is just the end game of being proactive. If you'll be greatly proactive, you become a totally disconnected off-grid microgrid that can satisfy itself at any, consequences. Until then, you can do a lot without becoming, fully independent.
I love your description of that, because I think I've heard people talk about it, and right, there's a lot of like, we need to make microgrids and be off-grid. And I think you have a great point of, there's steps between there. Like we can get there.
I'll tell you the same story from the other point of view. If you have a microgrid, which is, let's say, some city in the desert, and you would like to put batteries in order to become totally, self-supplying. You have solar, you have batteries. Just consider taking 2/3 of the batteries as lithium-ion batteries and 1/3 of the battery for cooling your facilities, because this is 1/3 of electric consumption goes into cooling. So you can take ice batteries and use this clean method in order to have less, influence on the environment in the future. What we're building here is a clean future without using polluting and unsafe materials and rare earth materials, which we will still leave to our children and grandchildren. I mean, we're building ramping up our ability to build lithium-ion batteries, and this is great for our portable EVs, electric vehicles, and so forth. But should we stay only with lithium-ion batteries? We are looking beyond lithium. We are looking at sustainable technologies to support the grid in going into sustainable mode. This is crazy to use sustainable materials in order to support the green going green. This is like oxymoron. We say don't do that, or at least if you can avoid it, avoid it. If you can't avoid it, go to batteries.
I really love this concept, right? And what you've built, right? You have a working device out there that's actually doing this, because it's, as you mentioned, like air conditioning is a huge energy suck. You're able to reduce the overall energy requirement, which is great, as well as improve the availability of sustainable electricity, making those solar farms more viable. And you're doing it in a way that when somebody invests in it, they actually make money back from doing it. I feel like you've found one of those solutions that actually it's wins around the board, and it makes it easier to say yes, because it's one of those things when if you want people to adopt a technology really fast, it's got to create a lot of wins.
We say that now it's the carrot window and the stick is coming. So if you want to enjoy the carrot the federal government gives you, supplying you the whole support of financing this and transforming your building, because before everybody heard about it, you can do that. And 3 years, 4 years from now, and if the Biden administration won't last, it will be even shorter. This window is closing. This window of using us as a channel to bring to you federal money will be lost in 3 years from now or so. So we say, be aware, aware that this is a great window of opportunity for you to hook, to these federal programs and enjoy investment of the federal government into your building and, bringing up the value of your asset. This is an amazing, time to do that. This is the time now.
I think that's a good point too. The stick is coming. Eventually there'll be taxes, or there'll be federal regulations that'll require all these things. And starting now, it's a good time to jump in, test it out, right? And I love that you brought up, hey, well, maybe do 1/3 of your battery storage with water. Have it,
of course,
spread out your technology, right? If you're going to be really conservative and say, oh, I want to make sure I'm covered all my bases, we'll use a couple different battery technologies. Go for it. And I think that there's a lot of people take really hard lines of, oh, if we're going to sell you an ice battery, you're going to get rid of all your other stuff, and you're only going to, then they really push, oh, ours is the perfect thing. Instead of going, hey, well, it's what you have here. Just start using it.
It's like open marriage. This concept was less seen than today. I mean, the hybrid idea, I'm joking about open. My marriage are monogamous. Sorry, my wife, I was joking. But what I'm saying, being hybrid is always better. So if my wife is listening, I'm just reminding her that being hybrid is not such a bad idea. Consider that.
Yeah, it's, technology, we like to think that there's like the magic bullet technology, and it's just going to be, oh, I have one thing and it fixes all my problems. And we're figuring out new things every day. Well, your technology didn't exist 10 years ago, right? So as we keep moving forward, we have to be like water, and we gotta change. We gotta keep moving. And just improve. If we just all keep improving,
Yeah, be water.
then we'll get there.
Be water, my friend. Yeah. Bruce Lee was very, very good at saying it concise.
I love it.
Flow is the stream.
I love it. Well, this has been a really amazing conversation. I love what you're doing. I really hope that we just turn every building, every skyscraper into a battery like that. Just that idea is amazing to have, that this is so possible. You have the technology. It's here. It's not a futuristic thing. Somebody could pay you and it can be installed, and it can be done now.
I have something to share with you. Yesterday, we were announced that the American Society of Civil Engineering's, the Metropolitan Los Angeles branch, award our system in the Beverly Hilton with the Outstanding Energy Project of 2024. So this is, nobody knows about it yet. So you're the first one I share it, because only yesterday we were informed. On the 11th of July, there is going to be a ceremony. So our first project in the Beverly Hilton and the World of Astoria was awarded by the American Society of Civil Engineers for Outstanding Energy Project of the Year, and we're very proud. We feel that we are walking the walk and not just talking the talk, and bringing a viable solution. So it's a great time for us to convey our story, and maybe for your listeners to join us.
Amazing. Well, congratulations on that, and for them for all that. It's great that this project was recognized. It's a big thing. That hopefully that means more people will be able to see and learn about what you guys have been able to accomplish. As we're wrapping up here, just want to make sure two things. If there's any last bits you want to mention, I know you just mentioned, that honor. And then for people that want to get a hold of you and convert their buildings into batteries, learn more, what's the best way to reach out and connect?
The easiest way to connect us is just go Google Nostromo. It's being spelled just like it's heard, with many O's, Nostromo Energy. And you'll find our website. You can connect us. You can check about the availability of the DOE program for your assets. We're doing it only here in California as for 2024 and 25. Later on, we'll grow into other states of the United States. But this is a great way. Contact us and we will talk, and we will see if you can qualify for this amazing finance deal. This is the way to invest in your asset and rise the value of your building using federal money. Hey, what's better than that?
Amazing. Well, thank you so much. I really appreciate your time being on the show and sharing your amazing project. And
thank you, Ian. Thank you.
And that wraps up another episode of the Conscious Design Podcast. If today's episode inspired you to bring your product idea to life and turn it into a sustainable 7-figure business, visit petermanfirm.com or click the link below. Your ideas have the power to change the world, and we're here to help make that happen. Thank you for joining us, and I'll see you on the next episode.